Hey guys, it's Casey from the Montreal Student Network, and today we are going to be looking at the 5 carbon constitutional isomers for alkanes. So like we said last video, constitutional isomers, they have the same chemical formula. So when you sum up the amount of carbons and hydrogens, since that's all there is inside an alkane, they'll have the same numbers, but since it's an isomer, they will have different atomic arrangements. So those carbons will be arranged differently, and the hydrogens, will just be placed to complete the 4 carbon. You don't need to, the 4 bonds on the carbon. You don't need to put too much thought into placing the hydrogens, and I'll show you guys exactly how that works right now. So there are 3 constitutional isomers for 5 carbon alkanes. We have the standard one that you can imagine, a straight chain. And remember, straight chains are always diagonal because they do have the tetrahedral arrangement. So this is what you'll most likely see if it did actually, occur in real life. But it is a straight chain. So we'll draw this out in a bit of an expanded form just so you guys can see what, just you can count your carbons. I'd recommend when you're just learning constitutional isomers, draw this out with the bond line so you can make sure you have all your hydrogens, they're all accounted for. And you can make sure you get the idea that the carbons need to have 4 bonds. And once you see this one in the middle, they have 2 bonds to carbons, so they'll have 2 extra bonds to hydrogens to complete that 4 bonds. And once you get that idea down, probably once you get to the next chapter, you can stop drawing this expanded form because it takes a lot of time, and you don't have a lot of time to draw something like this on a test. Now, if you're going to draw the chemical formula for this, we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1, 2, 3, 4, 5. All our hydrogens and carbons are accounted for, so this is the correct bond line formula. The chemical formula for it would be CH3, CH2, 3, since there'll be 3 CH2 units in the middle. We can count those, 1, 2, 3, and one more CH3 on the end. So that is the correct condensed formula, and this is the correct bond line formula. Now, what if we arrange differently? What if we take this branch over here and place it over here? So we're pretty much moving it right over here. And that will give us something that looks like this. Now, make sure you know that this is equal to this. They have the exact same structure. This is identical. They're not isomers of each other. It's not different atomic arrangements. They are identical. You essentially just move this one around. So if you rotate this like this, it would turn out to be what you have right over there, and this is equal to this. So don't get confused. A lot of times you might think there are more isomers than there actually is, and you need to know that these are identical compounds. But once you get into naming, which we'll do in a couple videos, you'll be able to just name both compounds, realize they have the same exact name no matter which way you look at it, and there you go. You won't get confused. So let's draw the expanded formula for this one. I'll redraw the bond line so we have it down here. The expanded will be like this. And we can draw these ones on the end. We'll have 3 hydrogens, one up here too. This one over here, 3 hydrogens. This one's attached to 2 carbons, so I have 2 hydrogens. And right there, you can count them all up and see that it has 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And how would we draw the condensed formula for something like this? Well, you can just take it slowly. Draw a CH3 representing this guy over here. It'll be connected to a CH unit right there. You can just expand it out like this. CH2 and CH3. That's the correct way of representing it. It works on a test. Most teachers will want the bond line, but if they ask for the condensed structural formula, this is completely acceptable as well. Now we see how that's arranged differently, and it has the same chemical formula. So it is a constitutional isomer of what we saw right here. Now this, if you want to give it a name, the first one, the name you can use to differentiate is N-pentane. But in normal situations, you just call it pentane. When we go down to look at the one here that has one branch, one of the other constitutional isomers, we will associate the name Just like in the previous video, when we had one branch, we called it isobutane. It's just an extra name. There is another one for the third constitutional isomer, which we'll look at. So it's good to know these common names in case they ask you for a common name. But on a test, there is a naming system, the UPAC naming system, which will make it much simpler. You don't really need to memorize all these extra common names. So in the last one we have, let's get the structure we had up before. What happens if we take this branch over here and put it in there? We still have an extra bond right there, so we're going to have a carbon that's attached to 4 other carbons. And we're going to get a structure like this. And that is like the peace sign. Remember last video I said there's the structure that looks like a peace sign? This one really looks like a peace sign without the circle around it. So anyways, we're going to draw the structural, the expanded structural formula. Just take a look. And we're going to try to have that kind of tetrahedral arrangement. It's something that your teacher probably will not take off marks for if you don't do. But hey, it's better. You can understand a bit more of how science works just by looking at the tetrahedral arrangement with the 109.5 whatever bond degree angles. And you see right now we have 4 CH3 groups. So 4 times 3, we know that it is 12 hydrogens, and we can count our 5 carbons. So there we do obey the chemical formula. And clearly there's a different atomic arrangement. It's not similar to the one we have up here, and it's not similar to the one we have up here with N-pentane. We're going to assign the condensed structural formula to this will be CH3 4. So it's a bit different than what we've seen so far. It's 1 carbon. The carbon in the middle is already attached to 4 of the carbons, so it will not have any hydrogens, and it will have 4 CH3 groups surrounding it. 1, 2, 3, 4. So you can condense it like this, or obviously, if you want to do the long way, you can just write something like this. Really, it's not a problem with your teachers, but once again, there's a lot of stuff to do in an organic chemistry test, and you might want to just save time. And once you can identify something like this, if you get this condensed formula, you don't need to take the time to write it out. You can automatically figure out what it is. And finally, we are going to assign the name Neopentane to this derivative of pentane. How it's going to have 2 branches instead of 1. If it has 1 branch, it's isopentane. If it has no branches, it's N-pentane. So we'll just take one quick look at what we've seen so far. We have N-pentane up there with no branches. We have isopentane here with 1 branch. And then finally with 2 branches, we will have, where is it? Right down there, we have neopentane. And if you try to arrange this in any other way, you'll know that there is really no other way of arranging it. So there's no other constitutional isomers. For example, you might think that you can take this branch here. Let's use a different color. Let's use blue. Didn't use any other colors this video. Let's say you take this branch and bring it all the way down here instead. You're going to get a structure that looks like this. But in reality, this structure is exactly the same as this. There's no difference. You just got to look at it a bit differently. And you can see that, okay, here is carbon 1, 2, 3, and 4. Obviously, we should number it in the other way. You always want to number so your branches have the lowest number on them. So here's 1, 2, 3, and 4. 1, 2, 3, and 4. We see that, the odd branch out is on carbon number 2 in both cases. So they're identical. You really want to make sure, you should know how many isomers each type of carbon has, or each carbon count has, just so you don't run into a problem like this on the test and say there's more constitutional isomers than there are. So that's the video for today. If you have any comments or questions, feel free to leave a comment and I will answer as soon as possible. Thank you very much for watching. My name, once again, is Casey, and have a great day.